Continuing our discussions in section 2.6 on continuity, we've already discussed what makes a graph continuous at a point. The next types of continuity we want to discuss are continuous from the left and what is meant by continuous from the right. In order for a function to be continuous from the left, I'm going to call this point A. The graph must be continuous all the way up to and including the point from the left. Okay? And if I want something to be continuous from the right, that means coming in from the right, it's continuous all the way up to the point I'm talking about. So here's the key point from continuous from the left and continuous from the right. They have the same basic definitions of what is meant for continuous at a point. The first one being identical is that f of a must exist. And if we want it to be continuous from the left, continuous from left, the limit as I approach A, as I approach A in the positive direction, limit as x approaches A in the positive direction of f of x must equal f of A. Continuous from the right, as I come in here, this limit as I approach in the negative direction must equal, we'll call this, in this case I'll call it B. So the limit as x approaches B of f of x must equal f of B. So to be continuous from the left, I don't need a two-sided limit. To be continuous from the right, I don't need a two-sided limit. But the direction that I am coming from, if I'm coming from the left, the limit as I approach the point to the positive direction must equal the value of the function. And continuous from the right, the limit as I approach in the negative direction must equal the value of the function. We call a function continuous at all points or basically the function is continuous if it is continuous at every single point from negative infinity to infinity. So the third type of continuity I want to talk about is just plain old continuous. If we say a function is continuous, that means it's continuous from at every point from negative infinity to infinity. All polynomial functions of x, are continuous. Okay? Y equals x squared, y equals x cubed, y equals x squared plus 2x plus 1. All of our polynomial functions you can draw without lifting your pencil off the paper. They are continuous at all points, so we call them continuous functions. A rational function, which is the quotient of two polynomial functions, is continuous at all points where the denominator's function, in this case q of x, does not equal 0. And we're going to leverage these two facts to help us solve different types of continuity problems. The last type of continuity I want to discuss is continuity on an interval. A purely continuous function is actually a specific case of continuity on the interval where the interval is the open interval from negative infinity to infinity. It's continuous at every point between negative infinity and infinity. It does not have to be continuous at infinity because I can never actually get to infinity. So if I'm to be continuous on an open interval, in general, to be continuous on an open interval, you must be, so I'm going to put from the interval AB, you must be pointwise continuous at all points between A and B. When I talk about a closed interval, for example, the closed interval A to B, which includes the points A and B, it must be continuous on the open interval and I'm going to write that as the open interval AB. And it must be continuous from the right at point A. And it must be continuous from the left as I go towards B. And that's this example right here. This function is continuous on the closed interval. I'm going to call the closed interval from B to A because it's continuous everywhere in between A and B. It's continuous from the left as I go to the right-hand endpoint, and it's continuous from the right as I go into the left-hand endpoint. An example of a graph for something that's continuous on the open interval would be something like this. If this is my point A, this is my point B, I do not need to be continuous from the right or left coming into this point or this point. I just have to be continuous in between the 2 points. So the 4 basic types of continuity that we're concerned about is when a graph is continuous at a point, when it's continuous from the left or continuous from the right, when it's overall continuous, and then continuity on our 2 types of intervals, which are open intervals and closed intervals. I will say that you can mix and match these definitions and come up with a partially open interval, where you're going to see intervals like this is, for example, something from like negative infinity to 2, which means it has to be continuous between negative infinity and 2, and because it's closed on the right-hand side, it must be continuous from the left as I approach 2. I can also have it the other direction. For example, A comma B. An example of this would be like the number 3 to infinity. In this case, it has to be continuous between 3 and infinity, and it has to be continuous from the right as I approach 3.